All right. This is the calculus video for week 6. Regrettably, in the middle of week 6. That's okay because I got to see some red questions before I make the video. And reminds me of a little principle of life that you will have to learn as a calculus student because you're so talented. That's why you're in calculus. Better late than never, Sometimes you will not get to things in time, but that doesn't mean don't do them. Just do them. So that's what we're doing right now. All right. So this is quiz 1, getting ready for integration and accumulation of change, and then applications of integration. So first half of calculus is all about differentiation. And that is basically finding the slopes of curvy functions. And then the second, and because the rate of change is very important. The second part of calculus is integration. And what that means is finding the area under a curvy function. So in geometry, we learn to find the area of polygons. And then in calculus, you can have the very curvy, crazy sides. As long as it's a function, we can use a technique called integration. So I better not say anymore because we got a lot of work to do. So this one right here says by completing the square. I complete the square. All right. So we could do it, but there's another strategy and I'm going to use it. And this is how. We're going to recognize that this is in standard form. Did you recognize that? Ax squared plus bx plus c. So that's do you know the second form right here? This is in vertex form. And that would be a times x minus h squared plus k. So you can see, first of all, the a's are the same in both cases. So we already know that this 2 is going to go out in front. How to get the inside? That would be negative b over 2a. Well, that's the vertex of the parabola, the x-coordinate. Sorry. But in parentheses in the function, it actually ends up being positive. So we'll find this. So that would be 7, positive 7 over 2 times 2, which is 7 over 4. 7 over 4, which is 2.75. Is that right? And so then we would substitute that in to get the y coordinate. And then, okay, and so that is why it's important to keep this sign here, because we want to substitute this in. So that would be 2 times 2.75 squared minus 7, 2.75 plus 5. So I'll just use deadmost to do that. Okay, so 2.75 squared minus 7, 2.75 plus 5. Oh. 0.875. Okay. So now we know this is 2. We know this is going to be negative 2.75 because we got to switch that sign. And then 0.875, hopefully. Try again. Now, what did I mess up here? 2 minus 2.75. All right, so let's just click it out here. Well, I got the All right, let me pause for a second. I'll find my mistake. All right, guys, you know what? My mental math was off, wasn't it? Did everyone realize that? It's 1.75, not 2. And then we get negative 1.125. Oh, what a difference. What a difference. Okay, and then negative 1.125. Moving on. Okay, so let's see if we could do this again. So we're in standard form, and this is vertex form, but this time you see this box is on the other side of the equal sign. So it will just be a sign switch again. But should we do it? All right, let's do it really quick. So this is going to be the A value is 1. That's done. Negative B over 2A is going to be 1 over 2, 1, which is 1/2. Okay, so we know this is negative 1/2. And then we're going to substitute that in. So 1/2 squared minus 1/2 minus 20. What is that? All right, let me just pause the video, see if I have to watch that. All right, got negative 20.25. So 20.25. So we have to switch that sign. And we know that's negative 1/2 0.5. There we go. We got it right the first time. All right. So now I am done with these. You can go for it from there. Just use that negative B over 2A. Hey, is there anything else? Is that it? All right. Well, it got easier for me. Okay. On to quiz 2. What is quiz 2 about? Dividing polynomials. All right. Everyone likes that, right? So I'll divide a polynomial for you. And so I know we all like synthetic division, but let's not forget regular division as well. And notice that when I'm writing this, the first thing I'm looking is to make sure there's no missing exponents. Hopefully you're doing the same. And now let's divide. So we're going to divide x squared by x, and that is x. So put that up top, like right here. And then we multiply. X times x minus 5 is x squared minus 5x. So we'll put that right here. And then sister comes along and boom, boom, gives everyone a negative, switching the signs so that, boom, first terms cancel and these terms become negative 4x. Bring down for brother, and the whole family is involved. Divide for dad, multiply for mom, subtract for sister, and bring down for brother. And now we'll divide for dad again. Gotta love dad. All right, negative 4x divided by x, and that's negative 4. And so put that up there, multiply for mother, and that would be negative 4x plus 20. So I'm going to put that right there. So divide for dad, multiply for mother, and then sister comes along. And boom, you become positive, and boom, you become negative. So that the first terms cancel out. And this becomes negative 6. And that is the remainder. And it tells us to write it like that. So this answer would be x minus 4 plus negative 6 over x minus 5. So when we write it in polynomial form, we put the remainder over top of the divisor. So that if we were to check our division with multiplication, you know, that denominator would cancel out. So you can always, even though it's polynomial division, I just want to show you that, you know, these terms x, so if we multiply this by x minus 5, which is the divisor, then this would cancel out and that'd just be -6. And then this x minus 4 times x minus 5 would get you, it would get you almost this. It would get you like 20 or something. Yeah, 20. But then when you subtract 6 from 20, you end up with 14. It all works out. So see, I just checked my division by multiplication. Now I can be so confident. All right. And again, they didn't give me any missing exponents, which is nice. So I'll just do one more process for you. We'll do synthetic division. All right, so looking at that divisor, x minus 4, so we're going to put a positive 4 in the box, because first step to synthetic division is to solve the equation, setting the divisor equal to 0. But of course, you remember that from algebra 2. Then we are going to put the coefficients and constant term in a row. No sign switching or nothing necessary. And then we just bring down the first one and we multiply. 4 times 4 is 16. And then we add, and that would be 2. And then we multiply. 2 times 4 is 8. And then we add, that's 1. And then we multiply. 1 times 4 is 4. And then we add 0. Duh. All right. This is our remainder column. This is our constant column, our linear column, and our quadratic column. And we had another one, it'd be the cubic column. What do I mean by that? That means the answer is 4x squared plus 2x plus 1. All right. Let's just put that in so that you believe me. Sometimes I don't believe me, but I believe in this case. Okay. So see, this one is x squared minus 5. So you want to put a 0 for the 0x. But move on. Dividing polynomials. It's not so bad. Okay. So now on to the second set, and this is quizzes 1, 2, and 3 in the applications. Okay. Let's do quiz 2. So applications, extraneous solutions, solutions you can get but that don't actually work. Oh my goodness, not trigonometry. All right, I love trigonometry. Layla tried to solve the following equation where x is in degrees to the nearest tenth in the interval from -360 to 0, but she made a mistake. Cosine of x equals 0.74. Here is Layla's work. Cosine, okay. All right, so she made a mistake, did she? Or maybe she didn't, let's see. So this is a very simple equation to solve, and then she took the inverse, so that cancels that out. And the cosine inverse of 0.74 is at 42.3. And so we know that we could add 360 or subtract 360 from that number and get another equivalent value. But okay, we should probably do this problem ourselves. So cosine of 0.74. Just looking at it, I don't really see mistake off the top, but we're going to put ourselves in degree mode, and then we're going to find the cosine inverse ourselves. 0.74. And there you go, 42.26. So 42.3. And all right, so let me pause this, scratch my head for a second. All right, I just didn't want to babble as I was thinking, but okay, so this is what would have helped Layla. So she's got a lot of good stuff here. We can't argue with that. But there is one thing that she could have done that she didn't do, and that is draw a picture. We draw a picture, we know that the cosine is the x value. Positive x value of 0.74 would be over here. And so she's saying negative 317, so somewhere right there. But it's also true that if we would rotate up here, somehow, if we could do that in this interval, then, and this interval is a full circle, there's another option. So actually, this is the one she got, right? Negative 3, so we rotate negative 317, then we get right here, and that's fine. But then there's another, if we reflect it right there, there is another degree measure, very small degree measure. And so I can see that, how could I figure out what that is? Well, I could say that if I know the 90 degree, there's 90 degrees right here, right? And so if I subtract 90 from, well, subtract 1, 2, the 3 270s out of 317. So subtract 270 out of 317, and then we'll get that angle. 270 minus 317, and that's 47. So then what's the complement of 47? The complement of 47 is 43. So the cosine of negative 43 degrees, is that also? Let's check it out. Cosine of negative 43 degrees is 0.73. And 0.73, 0.731. Yeah. It was rounding. Oh, because it's 0.317. So anyway, I rounded, I forgot the 0.7, but you can see that there is another one. And so what would we say? Is it the radians? No. She forgot to apply an identity. She forgot to use larger. No. All right. So it's that identity. All right. So, if you can't remember the identities like me here, draw a picture. You can always draw a picture. The following formula gives the area A of a trapezoid where B and C are the bases of the trapezoid. Rearrange the formula to highlight the height. All right. So they want us to solve, and this is something you want to be able to do rather quickly as a calculus student. So I'm already saying, multiply by 2, right? So then we have 2a equals b plus c over h, and then we have to divide. So then h equals 2a b plus c. But, there's a balance between being quick and being right. As you can see, I walked that fine line. See? Your answer includes use of variables in the wrong case. Oh. Like that? Okay. There you go. Solve the equation. So this is an important one because it was a red question. We may get an extraneous solution. We have to first square both sides. Whenever you square both sides in a square root equation, you get rid of the square root. So that's nice. And then we get 4x squared plus 4x plus 1. Just foiling that out in my head, hopefully correctly. And then we get x plus 2 on that side. So now we have a quadratic. Let's get everything over to one side. So that's going to change it to 4x squared plus 3x, subtracting x from both sides. Subtract the 2. It's going to be minus 1. And then we would solve that using the quadratic formula. I'll just pause that and do that. Wait a minute. I want to slide factor divide and see if it works, just because that's so fun. All right, so let's slide factor divide. So that's going to be x squared plus 3x minus 4. So slide, now factor, plus 4 minus 1, it factors, and then divide. So x plus 1 and 4x minus 1. And so our values are -1 and 1/4. But we have to make sure that both of those work. So let's check. 2 times -1 plus 1. -2 plus 1 is -1. And then -1 plus 2 is 1. Did I make a mistake here? And then that would be 1. So when I substitute in -1 on one side, I get 1. On the other side, I get -1. So that is not equal. That means the answer is just going to be the 1/4. So you see that -1, although it was a solution to the equation, it was an extraneous solution. And that will happen. Find all the solutions to the equation. All right. Not so bad, because I see a fraction equal to a fraction. And so what do? Always cross multiply. Don't care if it's calculus or algebra 1. So 15 times x plus 4 equals x plus 4, x plus 2. But before I start really going for this, I do just want to, before I really start using the algebra, because I'm going to get a cubic on this side, I kind of want to maybe even just think about which ones of these work, because they gave them to me. It's not good, is it? All right, so let me pause the video and think about it. Whew. All right, guys, so I did look at the solution for that one, and I'm glad, because I almost made a silly mistake. I forgot somehow that you need to multiply by the LCD when you have to solve a rational equation. So what's the LCD of these two fractions? It is the second one. And so when we multiply by those, we don't end up with a cubic. We end up only with a quadratic because of all the cancellation there. Cancel culture. All right, so we get 15 on top. That's it on the left, and then x plus 2 and x, which is going to give us x squared plus 2x. If we distribute that in, and everything else canceled. So then if we just get the 15 over on the other side, okay, there you go, and 3 and 5, right? So +5 and -3, so -5 and +3 are the solutions. -5, not 4. I was just kidding about that. And +3. Not too bad. Okay. And so you can do this one, and we're done. Okay. So sorry, it's a little bumpy, but it's all right. It's the summer. We're having fun. Okay. And it's gonna make the school year even more fun too. We want to solve the following equation: x cubed plus 3x squared minus x equals the absolute value of x minus 1. Two of the solutions are x is, okay, find the other solution. Use a graphing calculator. Oh, I will certainly use a graphing calculator. I'd love to do that. So all we need to do is we're going to put these two functions on the graph, and we're going to look and see where they intersect. And Desmos is going to make that so easy, isn't it? So x cubed plus 3x squared minus x. X cubed plus 3x squared minus x. There is that beautiful function. And the absolute value of x minus 1, ABS, x minus 1. There it is. There's another way to put it, but it's ABS. And in your TI, you would press second 0 enter, and you'd have your absolute value. Also in the TI, you can use the calculate button, which is above trace, and you'll be able to find the intersections. But on Desmos, I can easily find it right here, not right there, right here, and right here. And they even, I saw, okay. So negative 0.7 and 0.5. I was going to say I saw Desmos on the MCAP. So negative 0.7, negative 2.879. There it is. Negative 2.879. All right. This is the graph. Yeah. Given that x approximately 2, use the graph to find other approximate solutions. Okay. So wait. What's the difference here? X squared plus 2x minus 2 equal to 5. So that's when it equals to 5. So that's that red line there. So they gave us this one right here. Okay, we see that. Now I guess, isn't that along those same lines? Negative 4. This is fun calculus. We want to solve the following equation. X cubed minus 4x equals 2 to the x. 3 of the solutions are, find the others. All right, so you can do that one. I won't spoil all your fun. And you can do that one too. And yeah, so now that you know that you can use a graphing calculator and just find where they intersect, it's really not a problem, is it? But if you were in algebra 1 or even algebra 2, you might be like, whoa, what's going on? You can't really use algebraic techniques, but doesn't mean that you can't do it. And that's what calculus is about. When there's a will, there's a way. Okay, so this one, see, we're rotating this triangle, and this is how we get lots of our tools. So I looked up rotating 2D to 3D shapes applet. There's a lot of things out there. GeoGebra is a good one. And so, just to show you, we can rotate that guy, and then our triangle becomes a cone. Or we can rotate a rectangle. What would that become? A cylinder. So how do you get a cylinder? You make a rectangle and you put it on an axis and rotate it. Pretty fancy dancy. Take a circle and rotate it, and what do you get? You get a sphere. Wow, that's how you get a sphere. And what about a trapezoid? Rotate that and you get a truncated cone. That's a cone where the top is cut off. And that's from rotating a trapezoid. But also, if we rotate this triangle, there's going to be this space in the middle is going to make a little circle, and it'll be a hollow cone frustrum. That's what that's called. Just a fancy name. Cavalier's principle, what is that? Cavalier's principle is when you are stacking base areas, that is how you can think of the volume. If you think of a roll of quarters, we have rolls of quarters anymore. That is Cavalier's principle. You stack the quarters until it gets to the top, and the volume is equal to the volume of all the quarters stacked together. Okay, so if they have the same height, they have the same volume. If they have the same base area and height, it doesn't matter if it's slanted. Pretty, profound. For which of the, so A and B have the same base area and the same height. So we're going to say A and B. C has a different base area. So let's just see what they say. Oh, they all have the same. We can use, the question is, since the cross-section areas are equal, cross-section, and the heights are equal, that's what I was saying. Okay, so the thing that I missed was the shape. It doesn't have to be the same. But what I didn't do is read the question. So I said same base area, right? You heard me say that. Rewind the tape. But because the shape was different, I said it can't be true. But it is true. I hope you forgive me. Okay, I'm going to read the question this time. Here is a right pyramid with a rectangular base. What is the one shape of cross section we could create by slicing the pyramid parallel to its base? So there's also a cross section applet. It's got to be, I just say to myself, it's got to be cross sections of solids. So just do, you can look this up too, and you can look at it, but it's just to show you what a cross section is. And even you can rotate that blue slicer, and then you can see the different shape. We could get a trapezoid, we can get a triangle, and we can even get a rectangle. So it's really helpful to visualize these cross sections. And if it's parallel to the base, what do you think? It would be the base, right? And then we can look at that. Now we can see it. I always like seeing it. So if your cross section is parallel to the base, it's the same shape as the base. Let me get it right. Okay. Rotating this guy. What are we going to get? A cone. We know that. A cone with a radius of 3. And Cavalier's principle. All right, I better do this one. And I better read the problem. Consider the following right pyramid, the right prism. Both figures have the same base. That is a regular pentagon. I see that. Heidi tried to use Cavalier's principle to show that the two figures have the same volume. Why would she do that? They're different shapes. The heights are the same. It isn't true that the corresponding cross sections are the same area. Yeah. You see, this is a pyramid, Heidi, and this is a prism. And so they are related, but you have to multiply the prism volume by 1/3 to get the pyramid volume. So it's got to be not just the base areas are the same, but the cross sections all the way up. Okay, it's a little bumpy, but hey, we did it. All right, I did it. You're gonna do it. We're gonna do it, and then you're gonna start calculus. So it's all good. I hope you had fun and enjoyed the 6 weeks of preparation. Bye. Whoopsies.